Hey everyone, and welcome to this presentation on touch and human interaction sensors. As technology becomes more personal, the way we interact with devices has evolved far beyond buttons and keyboards. Touch sensors, biometric fingerprint scanners, and flex sensors now allow machines to respond to the most natural thing in the world, the human touch. Today, we'll explore three fascinating sensors that sit right at the boundary between humans and technology. Let's begin. Here's a quick look at the three sensors we'll be covering today. First, the touch sensor. Use it for detecting contact and proximity. Second, the fingerprint sensor. Use it for biometric identification. And third, the flex sensor, which measures how much a surface or finger bends. Each of these sensors represents a unique way that humans communicate with machines. Let's explore them one by one. Sensor number 1, the touch sensor. A touch sensor detects physical contact or even the proximity of a finger or object. There are two main types: resistive, which responds to physical pressure, and capacitive, which detects the electrical properties of your skin without needing hard pressure. Every modern smartphone and tablet uses a capacitive touch sensor as its screen. Industrial control panels use touch sensors to replace physical buttons. Smart home doorbells and appliances use them for sleek and button-free interfaces. Even the touchpad on your laptop is a touch sensor. Measurement, binary touch or no touch, or a continuous capacitance value for pressure-sensitive appliances. Sensor 2, the fingerprint sensor. A fingerprint sensor captures the unique ridge and valley patterns on the tip of your finger and converts them into a digital template for identification. No two people on Earth have identical fingerprints, making this one of the most reliable biometric identification methods available. There are three main technologies: optical sensors that use light to photograph the fingerprint, capacitive sensors that map electrical differences across ridge patterns, and ultrasonic sensors used in modern flagship phones that work even with wet fingers. Applications include phone unlock systems, laptop security, ATMs, national ID cards, and office attendance systems. Its measurement in a match score from 0 to 100% or a binary match or no match result. Sensor 3, the flex sensor. A flex sensor is a thin flexible strip that changes its electrical resistance when it is bent. The more it bends, the higher the resistance. By measuring this resistance, a microcontroller can calculate the exact angle of the bend. Flex sensors are most famously used in VR data gloves. They are attached to each finger and track how much each finger bends, letting you interact with virtual environments using natural hand gestures. They are also used in prosthetic hands to mimic the movement of real fingers, in physical rehabilitation devices to track patient recovery, and in musical instruments that respond to hand movement. Measurements are in resistance in kilo ohms, which is proportional to the bend angle. And that brings us to the end of our presentation on touch and human interaction sensors. From the capacitive screen in your hand, to the fingerprint sensor securing your data, to the flex sensor inside a prosthetic hand, these three sensors represent some of the most personal and powerful ways that humans interact with technology. Thank you for watching.